So I hope that there are some Alan Shearer fans over here. That's the most person I know from Newcastle. Today I'll be talking about event sourcing and why it can help you to not lose business data. And let's start with some old photo. If you don't see what's on that photo, then on top there is Muhammad Ali, and at the bottom, lying down, there is Sonny Liston. And this fight, or maybe really short fight, was at the 25th of May 1965. And as I mentioned, that was a really short fight. It lasted only 1 minute and 45 seconds, probably a bit shorter than my introduction here. And why am I telling you and showing you this old photo? Because this old photo is a good example of what's event. Because event is something that happened in past. It represents a specific information. So in this case, that there was a fight between Muhammad Ali and Sonny Liston. It happened at a certain point of time. So in this case, 25th May 1965. And we have also some other information like how many people were there, etc. And important to know about events is that they gather information that cannot be changed, because what happened in the past cannot be changed. It's already happened. So you can interpret event differently. Like this is the same result of the same fight. Muhammad Ali, as you can see, interprets totally different than Sonny Liston. And what's interesting is that also the publicity interpreted the fight totally differently, because even probably no one saw the exact punch that Muhammad gave to Sonny Liston. So some people say that this wasn't real fight. This was just done for the money, etc. And some said that, yeah, it was just a good short fight. So another term that is really important for event sourcing is event stream. And what's event stream? Event stream is an ordered sequence of events. So if you can treat it as a whole history of what has happened for your business object. So typically, one stream represents all of the facts that were registered for a specific business object. As you can see on this example, we have shopping cart and all the events that happened for this particular shopping cart. So shopping cart number 1. So it was open, then someone added 2 products, and after that removed one of them, etc. And as we can see, all of the events are ordered and they are on a timeline. So they represent specific point of time when they happened. So if we have multiple business objects, like in a regular application, we are not working with the single business object. So if we are adding new entity or we are registering fact for the new entity, then in fact we are creating a new stream. And as you can see, those events are kind of overlapping each other, because there might be multiple purchases made at the same time, but they cannot happen at the same time for the same shopping cart. So TLDR, we can treat like an event stream is a representation of the entity in a classical approach. In fact, in event sourcing, and especially in the event stores, so databases where we store events, events are put into data structure called append-only log. Typically, you have a single append-only log. Depending on the exact implementation, there might be multiple, but the canonical version is that you have single append-only log. So you are adding if you are registering new fact that happened in your system, then you are just appending new event to this database structure. And in fact, what might be surprising or not, relational databases work precisely like that. Transaction log in MS SQL or write ahead log in Postgres works exactly the same way. So if you are inserting some row into the database, then at first it ends up in the append only structure, and then once everything is done, then it's reflected in a read model. So tables in the relational databases are in fact read models from the transaction log. So you can think about event stores as a database inside out. But what that gives us, it gives us the global ordering. So typically we know not only in the context of the particular entity what has happened in which order, but we also can know what has happened for the whole system. So some people say that this is one of the biggest advantages of event sourcing, so auditability. And let's now go to the event sourcing and discuss the event sourcing architecture. No, I'm joking. This is not an event sourcing architecture. So maybe that one. Now, that's also not an event sourcing architecture. This is even really the most recent topic and the most recent discussion that is in an event-driven community. Because again, yesterday on Hacker News and Reddit, there was an article that was explaining that you can use tools like Kafka or Pulsar or other event streaming solutions for event sourcing. And in theory, someone can make a definition so wide that it gets used, but that's not event sourcing, that's event streaming. For event sourcing, you don't need any messaging systems. What's more, you might not even have eventual consistency. So what's event sourcing? Event sourcing, as I mentioned, in event sourcing, we are recording the facts that happen in our system. So let's take a shopping cart as an example. And on the right bottom side, you have how that would look like in the classical approach, so relational table. And on the left side, let's have a look how that looks in event sourcing. So at first, we are opening shopping cart for the first time. And in a typical case, we would add new row with the products count equal to 0, status open, etc. When we are adding product, then we would increase the count. In event sourcing, we are registering new fact. If we removed product, then we are in event sourcing, we are adding new event, but in classical approach, we are just updating the row. And as you can see on that, there is no difference in this row between the initial state because we added and removed the product from our shopping cart. So at this point, we already lose some business information and business context because we just by looking at the row in the relational table, we don't know whether something happened or not, or is it just initial state. Then let's say that we are added finally the Witcher instead of the other game. And after that, we are confirming. So we are updating. Classically, we would update the status in the relational table row. And some may say that, yeah, okay, but typically you would keep all the information about product in the separate table, so you would know the details of the product that were added. And that's correct, or in fact, partially correct, because let's have a look again. And right now in the middle, I'm showing you how the typical event represented by JSON would look like. So it would have the stream ID. Stream ID is just a record ID. So it might be just, you can think about it as a primary key in relational database. Then we have position, which reflects the position in the stream, so we can define and know the order. Usually there is a timestamp just for diagnostics and specific data for this event, because our event should be as small as possible, but not smaller. So it should be focused on the result of the specific business operation. So let's start again. We are opening cart, we are inserting new row into carts table. Then we are adding new product. As you can see, position is now 1 because previously it was, sorry, my bad. Position now should be 2 because we are auto incrementing that. And as you can see, product added has a specific information for this event. So product ID added add. And we are adding new row into product items. But then we remove this product. And again, as we can see, we already lost that business information. Even though we are expanded that into multiple tables, we are keeping more information in our tables, but still we are losing business information. What's more, even if we somehow, for example, used a soft delete, so we could see also deleted records, then if we have 2 tables, and typically our star of tables is like 5 or even more, then it's incredibly hard to correlate between the tables what has happened and how that impacted. Quite often our business operation also changing multiple tables. And in the event sourcing, it just ends up as a single specific event. So how does it work in practice? So we are at first getting a request. Usually it's called comment, but we can think about this as just a request. And what's the most important is that this request, so comment, should be business meaningful. Because if we want to store business information as a result of our operation, then we need to know in which business context those events were created. So at first, when we server service is getting the command, then it's asking and reading all of the events from the particular stream. And after that, it creates a default object, for example, using default constructor in .NET. And one by one, it's applying the events on the specific object, building the local state in memory state. After that, we have the state, and the business logic processing is not different at all from the typical case, because we are running business logic based on materialized state. And after that, the only difference is that as a result, we are appending new events as a result of the business operation. So the only difference is that we are reading events. In, for example, Kafka or Pulsar, we cannot read events. We can only subscribe, which gives us eventual consistency. And what's the most important is that event stores guarantees strong consistency on the right model. So how they are doing that? For example, one of the projects that I'm involved is an open source project, Marten, and one of the co-maintainers. And it's using Postgres, so relational database as an event storage. This is a bit shortened version of our events table. And as you can see, if we are using relational table, then we can benefit from all of the things that we have in relational table. Transactions, unique constraint, optimistic concurrency, etc., etc. But it's not the only way how you can store events. You can use also the databases that are built natively for event storage. And as a result, we are storing that as a regular binary format and keep storing that as a files on disk. So if you have a look on the internals of the relational databases, they are doing exactly the same. They are serializing the data and storing them on disk. And that's how EventStore is doing, because EventStore is a database that is natively built for event sourcing and for storing events. And it also, on the right model, it gives a strong consistency. You have atomic append, you have optimistic concurrency, and you can read your rights. So if you read somewhere in internet that in event sourcing you cannot do that, then probably someone is missing the point and misleading and mixing events streaming, so this moving stuff from one place to another, with event sourcing, so durable storage of events. Okay, but we are on the programming webinar, so we should show a bit of code. Let me open my IDE. That's not the one. Okay, so I will try to explain you in a small code samples how to practically model and use event sourcing in your code base. I'm using here the new .NET 5 and .NET 6 single file program CS, and so everything will be in the same file. So let's start to see how we could define our events. So I'm using record. Record is it was introduced in C#9, so it's an immutable code structure. And as our events, as I mentioned at the beginning, they are immutable because they already happened, then record seems to be quite a good way of doing them. We can also use classes, structs, or whatever, but records are things that are aligned with the event sourcing vision. And I defined here the details of events that you saw in the slides. So we have cart initialized, product item added to shopping cart, removed, and confirmed. And all of those events have specific information for them. So cart initialized have client ID, but all the other events don't need to also send client ID, because we know from the first event that for which client this shopping cart was created. And we have price product item, and price product item is also a record with some value object syntax, and it contains product ID and quantity and total price and unit price of the product. So nothing fancy. And cart confirmed contains information about the shopping cart, because we need to somehow correlate those events to know that all of those events occurred for this specific shopping cart. So as you can see, all of them has shopping cart ID and has specific information, so confirmed at. So when someone confirmed this shopping cart. And event sourcing is not only working on events, because just the message that I would like to send you today is that if you are using event sourcing, then it doesn't have to be like a full revolution. You can do it gradually and use it in some places that you could benefit from them. And we still need to know the current state. So as I mentioned, we'll be restoring the current state. So in this case, shopping cart from events. And again, I'm using record. If you prefer, you can use classes. And here we have all the flattened state based on our events. And it looks precisely the same as it would look in, for example, entity framework. So we have ID, client ID, current status, list of product items in shopping cart, and the information about confirmed. Is nullable because we don't know it until it's confirmed. So that's the specific. So let's see how we could define how to materialize the state. So I will use a static method. This is the common pattern in the event sourcing approach. There are others, but that's the most popular. So we are defining method usually called when, and it means that for this specific state, apply me this event, and we are defining what should happen, how we should apply this specific event on this shopping cart. And as a result, we are returning new entity state. Because as I mentioned, we will be applying those events one by one. how to do that? I will use also the, I think, quite new syntax. So pattern matching plus records can be deconstructed. When I firstly coded that, or in fact, I get a suggestion from Rider that I can deconstruct that, then I thought like, well, maybe that's a bit too far. But for this specific case, I think that it's quite cool because it's expressive and it's telling us what we are doing. So if we are getting if our event that we are getting is a shopping cart initialized, then that means that this is the first event in our stream. So we should be creating a new shopping cart with the data that we get. So in this case, we are applying data from event and creating empty product item list. For the product item to shopping cart, we are just adding a new product item to our product items list. If we are removing, then surprisingly, we are removing the product item. For confirmed, we are just updating the status and information. So again, this method takes the current state because we will be calling this method for each of the event. So for the event initialized, we are creating new entity, and then we are just updating the necessary information that are specific for this event that we are currently processing. So let's see how we could make that work. And I will go a bit to the top because in the single program CS, the method needs to be at the bottom. And let's see. Let's define some data that we will be putting into our events. So we have client ID, shopping cart ID, and we have two products, shoes that cost £100 and t-shirt that costs £40. And let's say that we will be adding one shoes and two t-shirts to our events. And let's see how we could define the easiest way events. So this is our stream. As I mentioned, it's an ordered sequence of events, and they are here in the order of appearance. So this is more or less how our stream in our event store would look like. So we would have initialized, then we added shoes, then we added t-shirt, but then decided that no, we don't want to buy shoes, so we removed it. And after that, we confirmed and bought just a t-shirt. And how to make that work and how to aggregate the state. So we will use the aggregate method from Linku, and it takes the initial object. So in this case, it will be null. And for each of event, we will be calling when method. And the result of the when method, so as we define it here, will be a new entity because we are returning this result. And after this aggregation process, we will get the current state of the shopping cart based on our list. So that's more or less how that works. Okay, but let's see how our processing, so how we can process and generate the event, because that looks quite artificial so far. So we can define comment, and comment is an intent to change something. So for example, initialize shopping cart. This is some validation just to do it. And after that, I'm defining a command handler as just a simple method. So it takes comment, it runs some business logic, in this particular case, no business logic, just the dumbest as it can be. And as a result, it creates an event. And let's define also handlers for other events. So add product item to shopping cart. Again, some validation to create it. And then here we have some part of business logic. So we are making sure that our shopping cart is still open, and we are calculating a price for the product item because we don't want to send price from UI because then someone can cheat it. And as a result, we are getting a new event. So that's a pattern that we will see also, here. So we are remove product item shopping cart. Again, the same check, but here we are just removing the product item. And I uploaded, the business logic is in fact a bit bigger because I created a structure product item list that handles some validation and merging, etc. So it looks quite dummy, but it's a bit more into that. But I didn't want to blur it. All of the samples are already available on my GitHub repository, so everything is publicly available. You will be able to check it. And yeah, confirmation is just simple. We are making sure that we are confirming open cart and returning new event. So that's how more or less that works. But yeah, it's still quite artificial. So let's make it real. Let's use some real database. In this case, EventStoreDB. So this is the easiest repository or abstraction on top of the event store. So we will have find. So we will be passing when method, an ID of stream, and this method will read all events and apply them one after another and return as entity. And we have two append methods. One is just for the new stream, and the other one is with the version of the stream. So we will use it to because we, as I mentioned, EventStoreDB and other event store supports optimistic concurrency. So we are good. And here I pasted an implementation. Event store client is, as name suggesting, the client of the event store. Internally, it's using the gRPC protocol to connect with the EventStoreDB. We have also clients for other languages. So that's also the reason why we selected gRPC, because it's quite well supported in multiple environments. But nevertheless, let's focus on .NET. So as I mentioned, we will be using, we will be reading all all events from the stream. So we are telling that let's read all events from stream with this ID. We can define whether we are reading from star or from end or specific position, but here we want to just read all. And we can also define the direction. If we are reading from end, then we could read it backwards. But yeah, here we are just reading from the beginning till the end. And it returns nothing enumerable. We need to deserialize event. And after that, we are just using, again, aggregate async method. Aggregate async is also from Linku. It's the same as aggregate, but asynchronous. And we are passing the when that I showed you before. So see, even this simple code structures can be used in a real production code, because that's what I'm showing you here is like really, really close to what you would use in the regular approach. And then again, append, if we are not providing version, then we assume that there is no stream. So if we try to append to the ID and we say that we expect stream to not exist, then if it exists, then EventStoreDB will throw exception. We are serializing data. EventStoreDB supports both JSON and binary data, so you can use protobuf or other type of serialization that you prefer. And append, if we are providing version, then we can use it for optimistic concurrency check, as I mentioned. So we have strong guarantees on our right side. And in general, that's more or less all about how the typical flow of the event sourcing looks like. So let's switch to another IDE window. And right now, I would like to explain you the versioning, because the events versioning for the event sourcing is like a boogeyman. It's a monster that most of the people are scaring other developers that are not familiar with those patterns. And indeed, they might look scary, and migrations are always hard, even in the relational databases. I'm sure that each of you has some nightmare stories about migration. So I won't be lying, because migrations are never easy. So events versioning is also not easy in that sense, but no migration is easy. So I will show you like a few basic patterns on how to deal with that. That should cover majority of cases. And you can read also Greg Young's book. He wrote a really book that I recommend about versioning event source systems. Even if you are not planning to do event sourcing systems, then it's also a great book about the distributed processing. So just to remind you, this is how our shopping cart initialized event looks like. We are providing shopping cart ID and client ID. And let's just go through multiple scenarios. So let's say that we are adding new not required field. So we said that, oh God, we forget that we should also give some date, like when shopping cart was initialized. But if it's not crucial for us to keep that information and it's not required, then we can just mark it as a nullable, and most of the serializers will allow you to deserialize it without any failure. So that's the simplest trick. You don't need to do any magic. You can handle everything like that in your using just code structure. So let's see on some changes that are potentially breaking. So we have new required property. Let's say that our flow has changed. And previously, when we opened cart, then it was ready to use. You could immediately add new products, etc. to it. But then we decide that we would like to run at first some business logic to verify whether the operations are not fraud, or we would like to have some anti-spam filter. And let's say that if we adding the pending, then initializing a shopping cart, especially for the new customers, then we will give it a pending status. After it's approved, then through our filters, then it will get to initialized. And this is the same case that you will have in the relational world. So if you are adding new required thing, column into your table, then you need to think what to do with the old data, with the old rows. So in this case, you are typically defining a default value or doing some migration. I don't recommend to do migration. If you are using relational event store as a backing storage, then technically you can do it, but it's always better to keep the events as they are, because even if they are wrong, then that can give us a really good insights into our business process and help us track the bugs. So I recommend to just add new field with the default value on the most cases. So in this case, we can think that old events without this field were added using the old process. So they are they can be safely set as they are just initialized. And the other breaking change is rename. Sometimes we are just making some typo, like we just add cart ID and we have cat ID, which is a bit different meaning. And we would like to fix that in our code, because we want to usually we want to have our code prim and proper. So in this case, if we would like to do the change in a non-breaking manner, then we can, depending on the serializer you're using, I'm using here system text JSON, which is not the smartest serializer, but even system text JSON allows to specify that this is the old name. Let's say that we find out that we don't need to keep the shopping prefix because we already know from events that it's about shopping cart. So we could just use cart ID or even ID. And it's better probably cart ID because we have other IDs here. So we can say that if you get the old event or new one, then use the shopping cart ID and map it to the cart ID. Still in JSON, the data will be in the old format, but that's something that's unavailable, at least if we are using system text JSON, because if we are using Newtonsoft, then we could do such trick. So we could have either cart ID or shopping cart. I have caps lock. Shopping cart ID, and then we could use it like that. So either if it's old event, then it will have the field named as shopping cart ID, or if it's a new event, then we will have a cart ID. So, but unfortunately, system text JSON, as I mentioned, is not the great. So you cannot do such magic. You would need to probably write some custom converter, but yeah, that's quite simple and it can cover majority of cases. Let's see another and typical approach. So let's start with change structure. So let's say that we decide that we need more information about client in this event. So instead just keeping ID, we would like to also place a name. So, and as we are adding more information about clients, then we would like to group them in a client object. And so, yeah, this is the new structure. Just to show you, previously we had just client ID. And so what we can do, we can, for sure, if we don't know name, then we need to provide some safe default. And for ID, we would like to map the client ID into the new object. And for that, we can use a pattern called upcasting. And upcasting is using that we are injecting our middleware. In this case, it might be just a simple function between the serialization and our business logic. So we can get the old event, as you see, V1 shopping cart initialized, and we can either deserialize it if we have somewhere in code the old definition, so the V1 definition of our event, and just map it using code, or we can use more flexible approach, but a bit more tedious. So we can just take a JSON or binary data or whatever type of serialization we are using. And based on this data, for example, JSON, we can parse the data and then get it directly from the JSON. JSON document allows efficient JSON processing. So as you can see, we have a full flexibility. We are just creating new client based on client ID, and that's the most flexible. Different people prefer different approaches. This is looking better, but on the other hand, then we need to keep and maintain somewhere those old events, and we need to create at first, deserialize it, and then create a new object. So pick your poison for the change structure. And if we have new required field, then we can also use upcasters. Let's hide it. So let's say that we forgot to add initialized by, so user that created shopping cart, because maybe like not only client can open shopping cart, but also some shopkeeper. And we realized that luckily, besides the event data, we are also storing some metadata for tracing and auditability. And we had this metadata in user ID that we could use in this case to provide as an initialized by. Then again, we can define appcaster. The only difference is that besides having old event, we also have old event metadata. So we can use the same pattern. So use user ID from metadata if we are using object-oriented approach, or if we are using a stringly typed approach, then we can use a JSON document and parse also metadata directly here and just get what we need. We can, of course, do downcasting. No difference. Besides that, we are taking new event and returning old event. That can be helpful if we don't want to change our code base or change it gradually, so to support both ways. But how to connect those upcasters or downcasters into the real serialization? So let's have a look. We have let's have a look on the serializer. So serializer is doing the basic stuff. So it's using system text JSON to deserialize JSON based on the type that we are sending with event. Because usually there are some metadata that are stored in event store. So for example, event type name. Thanks to that, we can know which type we would like to deserialize it to. And we can inject additional class called transformations, where we register all the upcasters and downcasters that I showed you before. And we can try whether there is some upcaster or downcaster defined for this specific event type. And if it is, then we can try to transform it. If we transform it, then we are returning this transformed and prepared event. If not, then we are just using regular deserialization. Event type mapping is just a simple registration of the event type, the name, to the CLR type. But let's go to transformation. We have a dictionary that contains event type and function that transform this particular event. So it takes string and object. And we have two registration. One is with using type. And in this case, we will be just transforming JSON document. So see, we are just getting we are registering a function that takes JSON, calls the function that we provided with the prepared JSON document. And if we have the old event type, then we can just deserialize it and run transform event method. That's all. Try transform just checks whether there is a transformation registered, and then run it, or if not, then just returns null. And how to register that? Simply, we can just call event transformation register, and we can provide this upcast method that you already know. Or we can use, if we have the old event structure, then we can use the upcast method with the objects. So that's quite flexible. For event type mapping, we can also register. See, those event types differs with the suffix. And those are all transformation that we have. But you can always use some conventional based approach. I have such samples in my code base. And right now, let's get back to the slides. And let's discuss the final strategy that we could do. And let's say that we want to not only transfer a single event, but we would like to transform some of the events. For example, previously we had cart initialized and product added, but right now we can initialize our shopping cart already with products. So if we would like to be able somehow to merge those three events to the single event. So how can we do that? If we are sending correlation ID, so correlation ID is an identifier of the request, a unique identifier of the request that was sent. So for example, the specific command, and we see that all of those events, all of those three events were added as a result of the single command processing, then we can group them and we can generate new event. And for the others, we see that they differ by correlation ID, and we should not be grouping them. So I have this sample, but I will let you check that in the source code if you'd like to. Just the simple explanation. We can register the function that takes all of the events from the stream and returns transformed version. This is the logic of grouping them, but how to change it? So we can, besides transformation, we can add stream transformation, and at first we will try to transform all of the events if we are trying to deserialize. And then after we transformed or just returned the regular events, then we are running the known deserialize method. So I hope that it shows you that with the really simple tricks, you can cover majority of the versioning schema, but I would recommend to try to avoid the case when you need to version them, because the most important thing in event sourcing is to keep streams short-living and short. So the shorter events are, the less troubles we'll have. So if we have a look on the cash register example, then we could at first define our stream as keep all events for the cash register from the point where it was placed in the department store. But that wouldn't be effective, and that's not how the business works, because typically business cares in this case just for the specific shift. So at the beginning, we are some cashier is coming with a drawer, is starting the shift, and at the end they're making some calculations and noting how many cash is left in the drawer. Then the new cashier starts with the new shift with the cash and stats based on the previously closed shift. And if we ask our business, then in majority of the business, there are some such life cycles, like for example, accounting month, or for example, tickets in the support system. Usually they live quite short. Or I was working in the hospitality industry, and our business just cared about a single day. So we were making summaries on each business date. So we can add a day into our stream ID and define like all of the information for the registration for the particular day. So it's worth always discussing with business, because one of the key and powers of the event sourcing is that the closer we work with the business, the better we will have our system modeled and the less troubles we'll have. And let's now discuss projections. Projections, and again, let's have a look on the Muhammad Ali and Sonny Listons. Projections is just a different interpretation of the same set of events. So as we already knew, Sonny Liston has totally different perspective than Muhammad Ali. And projections are different interpretations of the same information. So as here, you can see that we have different pictures of the same ending, even colored. Then again, the same, we can interpret differently the projections. Sorry for the Polish language. For some reason, the changes were not updated, but yeah. Nevertheless, you have the chance to learn some Polish. So projection can be thought as a way to build the read model, and quite often they are said that they are like a materialized view of the event stream. And that's something that event streaming is useful and what's doing, because it's just taking and grabbing some set of events with the eventual consistency and building the read model based on that. And they might be from the same stream. So like we already discussed, like cart initialized, product added, cart confirmed, or it might even join multiple streams. And for me, this is really powerful because see, we have the same set or almost the same set of events like cart initialized, cart confirmed. And based on this event, we can define cart's read model that has a details for the shopping cart. And we can also build like a user carts dashboard where we have admin view for all carts, etc. And let's have a look how typically the projections are created. And this is the pattern that you should be already familiar, because it's more or less the same how we would apply the materialized state for our write model. But in this case, a result is not stored as an event, but as a flattened version of the stream. So we are getting cart initialized, we are adding new row. When we are adding new products, then we are increasing the products count. And when we confirm cart, then we're just updating the status. So this can be a relational model table. It can be a document in the document database. It might be even some blob stored on Azure Blob Storage or S3. And when get user query is coming, then it will read from the database that is designed for querying, for filtering, because it wouldn't be effective if we try to load all events just each time we would like to get the information. So in event sourcing, we are materializing state somewhere. It might be even in memory if we don't have a lot of data, but typically it's like a real database at the end. And the same event, as I mentioned, can update multiple read models. So for example, product added may change product availability, because if we added if we added product to shopping cart, then we need to decrease its availability in inventory. We need to change the shopping cart because we need to reflect that we added this product. And also on the user dashboard, we should see that, like, for example, counter the number of products that you have. And also projections might also create other events. So that's the case for EventStoreDB projections, the built-in projections. They are taking a set of events and transforming them into another set of events. So exactly the same in a way as I showed you in the last example with the stream transformation. And projections, they don't need to be asynchronous. They are typically because of the scaling factor. But if you don't have like an extreme traffic, then for example, solutions like Marten allows you to update projections in the Postgres in the same transaction as a pending event. So using unit of work. So as I mentioned, event sourcing is totally orthogonal from eventual consistency, etc. It's just a matter of how your event store is implemented, what trade-offs you selected, what are requirements for your system. So it doesn't have, you don't need to be fighting with the eventual consistency, ordering, etc. It just depends on the event store type you choose and the decision you made. But as I mentioned, if you want to scale up, and events are quite often used in the distributed soft systems because they are really good in this case, because you can not only update read models, but you can also join business logic and workflows from the multiple systems. So you could use the subscription mechanism, like for example, in EventStoreDB, where you are just listening for event and then you are defining what to do next. So I will show you just the dumbest projection. Let's say that we would like to calculate the cart abandoned rate summary. So we would like to know how many carts were abandoned, some rate between the total count and abandoned count, and to based on that do some business decision and have like a nice dashboard. And we would like to put that, for example, in Elasticsearch to be able to query and make some more advanced correlation. So how event processing and read model generation looks like. Typically, we are just registering a function or a class like an event handler that listens for a specific event. In this case, for example, shopping cart confirmed or shopping cart abandoned. And based on that, we are running the handler. And as a result, we can either store the summary, the final summary in Elasticsearch or other database, or we can append it as a new event. That depends on our case. But typically, we are taking an event, applying it using handle method, and storing a result in some durable database. And how handler looks like? It's quite simple. It takes the event. It takes, we can read the current summary, for example, also from Elastic. So we are reading the current summary. For the confirmed event, we are just increasing the total count of the cards that were closed in our system, and we are recalculating the abandoned rate. So abandoned count and total count, etc. For the abandoned summary, we are making more decisions because we need to calculate all that stuff. So if you are curious about that processing and how we can build a transformation pipeline, then I also encourage you to have a look on the samples. And let's get back to our slides. And based on that, as I mentioned, we can really build complex pipeline, and we can get a great insights from the data that we have. So if we store just flattened version, then we will lose the business context. But if we are storing each business fact, then at some point we can say that, okay, so we have product where e-commerce product where we can sell products, but let's see what we can do with the data. And we can do, for example, market basket analysis in this case. So it's a simple algorithm, but quite complex to implement efficiently. So the general rule is that we are at first storing information about each confirmed shopping cart, and we are taking all of the products that were in this particular shopping carts, and we can get few measurements. For example, support means is how the popular was in the total item set. So for example, if we have apples in the 4 out of 8 shopping carts, then support will be 50%, so 4 and 8. Then we can calculate other metrics like confidence. So for example, confidence is how likely you will purchase another product when you purchase the first one. So in this case, how likely you will purchase beer if you bought an apple. So we are calculating this measurement based on the support on the number of shopping baskets that they were together. In this case, they were together in a 3 shopping baskets, and we are making correlation with the general support of the first item. And based on that, we have a confidence, so how likely someone will purchase another product. And we can also have a lift, and lift is how likely you will purchase another product, and it takes also into an account the general popularity of the product. So lift is used to drop the cases when, for example, both apples and beers are popular, and just by coincidence they are together in the same shopping basket. And you could do transformation based on those events. So for example, gather all the confirmed events, get all of the products, and then build a pipeline that will result in the data that you can take further on, and even for the machine learning, and do like a real nice data insights. If you don't have this information, then you cannot do this insights. So you are losing not only data, but also opportunity and money. And this is an example of how we could calculate. So this tells that, for example, the beer and male cosmetics is probably the most probable from all of that. Canned beer and soda is also quite good. Its lift is 1. Everything that is above 1 in this case is that it's high likely. But here we have confidence 20%, which means that they are, and we can see on the support that both canned beer and soda are just bought quite popular. So it might be that they just by coincidence, they got such high measurements. So yeah, we can do a lot of useful stuff with the event data. Yeah, and here, this is how the results of this operation looks like, the graph, and you can define and go through that and get some insights. And projections are predictable, so you can, because they are always coming from the same set of events. So for the same set of events and for the same logic, you will always get the same result. Because as you saw, all of the handlers were just like a pure functions. So they were just returning a result, not changing any state. So they are predictable. And based on that, we can predictably rebuild projections. So let's say that we have some bug in our logic. Then we could, for example, drop the current read model and rebuild it. The easiest way is to do an in-place rebuild. So we are truncating the read model and then applying events one after another. However, as we know, that's not the best typically, especially if we cannot afford of having some maintenance window. And we can also do the blue-green rebuild, which is a bit better option. So we are creating a new read model in parallel, and we are reapplying all events. And the old read model will still get a request from all the queries and will handle the queries. And the new one will be just switch after we applied. So after we caught up all of the events to the new one. Of course, it's not like it's a silver bullet, because if our streams are extremely long, then the rebuild will take time. However, quite often that's fine for business. My colleague said that his business was fine, that the rebuild will take 2 weeks, because they could live with the obsolete data, but they wanted to have it clear and fixed after some time, and they were fine with that. So again, talk with business and keep your stream short. And event sourcing allows also time traveling. So time traveling is critical for debugging, because let's say that one customer said that he didn't want to buy Witcher, but another game. So we can say that, yeah, okay, if we just take the subset of events, then we can say like, yeah, okay, he added the Cyberpunk, but after that, he decided to remove it and added the Witcher. So we have proof. And if it's not only about the legal proof and discussion with clients, but it's also extremely useful for us developers, because we can take a subset of events, run it in our code, debug, and we have really nice debugging and traceability experience. And also auditability is a really important aspect, especially in the distributed world. It's really hard to do it right. But let's say that we have such subset of events, and I put them in order. So just by looking at this screen, you can see more or less which event happened in which particular order. But for computer, it's not so trivial unless we give them the information. So we can say, as I mentioned, correlation ID. In correlation ID, we can pass through all the events, through all the operations. It's the ID of the operation that triggered all of the operations. So confirm shopping cart comment created cart confirmed, which then triggered a workflow to send a confirmation email, print an invoice, and then resulted in an invoice printed event. So all of the events like that were triggered by the single operation. So we know just by passing and storing correlation ID and metadata that all the events were triggered by that. And if we join that with the causation, so causation can be, for example, the ID of the event that involved this business workflow. So for example, for cart confirmation email sent, it will be ID of the cart confirmed, the same for proforma invoice issued, and for proforma invoice printed, the previous ID will be the proforma invoice issued. So then we can, based on that, we can just do a simple tree traversal and build such tree, and we not only know what's the correlation, so what were the set of events that were created by the specific operation, but we can also define what caused this event, so build exact data. And if we join that together, then we have full scope and full auditability and traceability. And yeah, summary. I hope that I managed to show you that event sourcing is not so scary. It's not so hard as it's pictured too often. You don't need to do a full revolution because you can still use entities. In the worst case, you can just, the only difference that you can see is on the state rehydration, because you need to build it from events. And then you, as a result, you are storing the new event. And for me, the most important fact is that it allows me to focus at first on storing the events, and then I can split my brain process and then think how to use those events, how to build treat models, etc. So it gives also debugging experience, auditability, etc. And what's the most important, you are not losing data. And in our world, storage is cheap, data is costing us a lot. The more we have it, the more information we can get, the more insights we get, and our business can be more fruitful. So that's all. Thank you a lot for being here. This is the link for the source codes. If you have any questions, feedback, please send me an email. I would be extremely happy, especially about the constructive criticism, because that will help me to improve in the future and deliver talk even better. And so, yeah, that's all. Do you have any questions?
Thank you, Oskar. There was a question in the chat about the font you were using in VS Code.
I'm not sure. I'm using here Rider. I can let me check. I'm using Rider Dark Melon, whatever it is. Rider Melon Dark. Yeah, I agree. That's the most readable I found for the webinar. So yeah, it's Rider Melon Dark, but I have no idea which font is that, to be true. Do you have any other questions or any other thing that I can explain or tell you? Oh, I can see the question about the syntax. Let me get back to the proper IDE. And I think that it's somewhere here. So the question is question about the C# switch syntax used in the earlier code sample, which took the object at event. Just never seen that before. So Mark, yeah, that's also quite new that I found. This is a pattern matching. I think that it's from C#8. So you can directly return data from the switch. It would be more or less the same as if you like do switch event and then keep here somewhere a variable and like a result. And then just do it here. And then at the end, make a result. So that's the first part. Then let's untangle this magic syntax. So in this case, it would be like typically you would have shopping cart initialized. So you would have some pattern matching because in case this event is such type, and then you could use it like that, I think. Sorry, shopping cart ID, and here, etc. But if we are using record, and we already know that this type is a record because we did this pattern matching, then we can deconstruct this event into such syntax. And this is the same syntax as you would use if you have like a, let's say, event, and you could use it like that. So typically, if you are using records, then you will find such syntax. And yeah, so that syntax here is exactly the same mechanism. So we are deconstructing. If someone is using TypeScript, then it's also quite common pattern to use in TypeScript and JavaScript. Yeah. So Mark, did I answer your question, or should I elaborate more on that? Maybe about this with, because with, if we are using record, then we can say that the new object, because we cannot mutate record, at least not easily. then we can say that the result object will be the same object as we are putting here, but with the data replaced in a way that we said here. So that's how it works as it reads. So it's entity with product items equal to that one. And as I mentioned, I provided like a wrapper class, a value object class, that it just processing the product item and returns always a new product items list. So it's a immutable collection also. Okay, so Mark, so the type at event which isn't known until runtime is matched from the type specified on each line. Like shopping cart initialize of product item shopping cart added. Yes, it's not known at the runtime because, let's go above. If we are calling the real event store, then what we get here is the resolved event structure. And let's just try to grab it. Let's decompile some code. Yeah, so resolved event is a structure defined by in event store. It's a wrapper for the regular event. So it has like the position, to know the ordering, that's stuff that we don't need to discuss at the moment. And it has the event record. And event record is a event data. It has some metadata like event stream ID, event number, event type, so all that stuff I mentioned. And it also has this data and metadata, which is just bytes, like a blob. And because eventually the data in event store ends up as a blob. If we are sending a JSON, it also ends up as a blob. So we need to deserialize it. And the serialization process looks like that. At first, we have to know which type we would like to deserialize it to. And we are taking the blob and just deserializing it. And at that moment, we know already what's the type because the object is created. So the event object is created, but we don't know, we don't have this type information because we are returning object. Because each event, or not each, but potentially each event has a different type. So we need to return a list of objects because we want to know it might contain multiple objects of the different types. So because of that, we are getting all of the events from the stream, so sequence of events, and for each of it, we are calling this when method, and when method takes the object event because we are not sure. I mean, we don't know, but already we can make this switch because this object is initiated. So so we can do pattern matching that will just will route us to the proper place where we would like to go, and which specific which specific apply method we would like to do. So Mark, I hope that answered your question, or should I do some follow-up? Yeah, I'm happy, Mark, that I was able to explain that. As I mentioned, when I first saw that, then I said that, yeah, that's weird. That's incredibly weird. I wouldn't probably use such structures a lot in the code base, but in this particular case, I think that is pretty cool because it's quite, you can just read it as a documentation, like what happens if you get such event, then how to apply the data from this event. So I think that's quite cool, but you don't need to have such pattern matching you can use like other ways of dealing with that, and you don't need to use records. That's just how I'm using it at this moment. But yeah, it's not like it's forced that you have to use it like that. Do we have more questions? I would be happy to answer. Okay, we have a question from Daniel. You mentioned debugging by replaying a specific subset of events. How would you approach this in a piece of code that's subscribing to a specific stream? Do you have preferred method to retrieve the events based on a set criteria? So that depends what we would like to achieve, because if we want to just debug the scenario that we have, then we could just use the event store client and grab those events, read those events as they are, and we could even just take those events and use the binary blobs here, and we could define event as a set of events like that and run the debug logic. So this could be precisely the same. We could just write some test and define the set order, and you just plug debugger and see where we did wrong. And the same for subscriptions, because subscriptions, they are publishing events. So in this case, they look a bit different than reading, but this is more like a technical difference, because in subscription, we are also getting just a set of events and that we are applying on some database. So let me just go to projection example. As you see, this logic, if you write it like that, then this logic is predictable, because we are just taking an event with the left fold approach. We are taking some specific state, like the previous state of our read model, and returning a new one and storing it based on how we would like to do it. So we could, again, we could check those data, the read model data, and set of events that was used to build this read model. And we could also just pass it. We could take these blobs, because maybe there is some issue in the serialization. So it's always better to just use blobs and yeah, just run the code. And if we are using relational database like in Marten, and we are storing that using JSON-B field in Postgres, then we could just do select on the database, take those JSONs, and also run at first. Probably I would just run some dummy test with this data. And then after I realized what's wrong, then I would write a proper test for that, and of course make the fix. Because I didn't mention that, but for me the important part about event sourcing is that in general it's predictable, because we can it's really easy to test, because you can just define a set of events as an input and a command, and check your state if it's as you prefer. And the same for projection logic. They are predictable, as I mentioned. If we take the same set of events, the same logic, it will always generate the same result. So yeah, I would say that there is no specific magic. Of course, sometimes we may be facing issues that are directed to, for example, our misinterpretation of how event store works, the specific event store, or there might be some bug in event store. They are just software written, so they might have bugs. So in this case, the easiest way is to probably just run it through the event store. I'm always saying that one good integration test is sometimes better than 10 or 20 unit tests, especially if it touches some specific mechanism of the storage, no matter if it's event store or relational database. So nowadays, it's quite easy to spin up some Docker images and run integration tests. In my code samples, you can find there are also integration tests that takes comment and then just treat API as a black box. So that's another way of working with that. And Daniel, does it answer your question, or should I add something more? Can an event handler create additional events? Yes, it can. See here, for example, let's just hope that this is the one. No, that's not the one. Yeah, that's the one. So we are getting the shopping cart abandoned event, and we would like to translate it to the cart abandoned rate calculated, because we would like to do some intermediate processing. Cart abandoned rate calculated just have information about the totals of the stream. So in this case, we are aggregating the stream, getting summaries for this abandoned cart, and we are publishing another event. And this another event can be later on handled. And in fact, it is handled in this logic I show you before. So we are getting the shopping cart abandoned calculated. And then based on that, we are applying our summary. So we could build a pipelines based on events. So for example, cart abandoned, we are doing some calculations, making some totals, publishing event. It can trigger other workflows that might be, for example, storing the summary in a database, or it might be some even other business logic. So yeah, why not? And as I mentioned, the internal, the projections in EventStoreDB should be probably named transformations, because what they are doing is just taking a set or single event and translating it and transforming it to another set of events. Okay, Daniel, thank you. Happy that I managed to answer that. Well, so it seems that we have reached the 1 hour and a half. I'm not sure if there is some still space for questions, or if there are some other questions.
Yeah, we've got time if you don't mind hanging on a few more minutes if there are questions.
I would be happy to answer them if there are some.
Yeah. Anybody got another question?
Okay, it seems that that's probably all. If something pops out to your head, or you would like to ask a question, send me a feedback, and feel free to do it. I'm quite active in internet, so you can drop me an email. You can find me on Twitter or other places. I really encourage you to have a look on my samples. There is a lot of them. All of that I show you is already there. Some of that is not yet merged because I'm working on some README to expand the description, but the code is already there. So from my side, thank you a lot for having me here and giving me the chance to talk with you about event sourcing.
Excellent. Thank you very much, Oskar. That's been wonderful. Okay, so if there's no more questions, then I guess we'll wrap up. We've got an event coming up in January, and I think it's going to be early January this time as well. So please keep an eye out for that in the usual places, and I'll let everyone know that as soon as possible. Thanks, Oskar.
Thank you
everyone for attending, and we'll see you next month, I guess. Bye.
Thanks.